In this class, we will start the chemistry of the lanthanides or the chemistry of the lanthanoids. If we have a look on the modern periodic tables, so in the modern periodic table, in the left hand sides, there are two groups, that is group number 1 and group number 2. And in the right hand side of the modern periodic table, there are 6 group, that is from group number 13 to group number 18. This first two group is also called as S block element, and group 13 to group number 18s are also called as P block elements. And in the middle of S and P block elements, there are 10 groups, that is from group number 3 to group number 12. These elements from group number 3 to group number 12 are also called as D block elements, or they are also called as the transition elements, which we have studied earlier. In the transition elements, there are two series of the elements. These two series of elements are called as 4F block elements or 5F block elements. These 4F and 5F block elements are also called as lanthanoids and actinoids. So 4F block elements are also called as lanthanoids or lanthanides, and these 5F block elements are also called as actinoids or actinides. Because in the modern periodic table, the positions of the lanthanoids are and actinoids are within the transition elements, so they are also called as inner transition elements. So the first question is that why the lanthanoids are called as the inner transition elements. It is because lanthanoid exist within the transition elements or D block elements in modern periodic table. That's why they are also called as inner transition elements. If we have a look on the modern periodic table, the hafnium atomic number 72, and after that the element is tantalum of atomic number 73. Before this hafnium, there is a lanthanum La of atomic number 57. This is lanthanum of atomic number 57. So the 14 elements are missing from here, lanthanum to hafnium. These 14 elements, that is cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and lutetium. In these 14 elements, after lanthanum of atomic number 57, during their electronic configuration, the valence electron occupy 4f subshells. That's why these are also called as 4f block elements. And because the first element of this series is lanthanum, that's why these are also called as lanthanoids. So what are the lanthanoids? The 14 elements after lanthanum of atomic number 57 occupy their valence electron in 4f subshell. So after lanthanum, these 14 elements, that is from cerium of atomic number 58 to lutetium of atomic number 71, are called as lanthanoids. Lanthanoids are also called as 4f block elements because during electronic configuration, their valence electron occupy 4f subshell. These 14 lanthanoids are cerium atomic number 58, praseodymium atomic number 59, neodymium atomic number 60, promethium atomic number 61, samarium atomic number 62, europium atomic number 63, gadolinium atomic number 64. It is terbium atomic number 65, dysprosium atomic number 66, holmium atomic number 67, erbium atomic number 68, thulium atomic number 69, ytterbium atomic number 70, and it is finally lutetium, that is atomic number 71. The first element of these lanthanoid series is lanthanum. It is not a typical lanthanoid element, but most of the property of these lanthanoids match with the other elements, other 14 elements of this series. That's why lanthanoids is studied along with rest of the lanthanoids. The question is that why lanthanum of atomic number 57 is not considered or is not regarded as a typical lanthanoids element. It is because during the electronic configuration, the lanthanum of atomic number 56 do not occupy any electron in 4f subshell. So 4f subshell of the lanthanum is empty. That's why lanthanum of atomic number 57 is not regarded as a typical lanthanoids. But the lanthanum is studied along with the rest of the lanthanoid. It is because most of the properties of lanthanum are similar to the rest of the lanthanoids. Out of these 14 lanthanoids, that is from cerium to lutetium, only one lanthanoid is radioactive. It is our promethium. And among all the lanthanoids, the dysprosium atomic number 66 having the highest value of magnetic moment. If we talk about the definitions of the lanthanoids, so all those elements in which during their electronic configuration the 4f subshells are occupied, or the elements in which the valence electron occupy the 4f subshells during their electronic configuration are called as lanthanoids, where the general electronic configuration of lanthanoid is, that is electronic configuration of the xenon, which is a noble gas, 4f 1 to 14, 5d 0 to 1, and 6s 2. The 6s orbital in lanthanoids always occupy 2 electrons, and d orbitals or 5d orbitals either occupy 1 or 0 electrons, and 4f orbitals or subshells occupy from 1 to 14 electrons. In the coming class, we will study the electronic configuration of the lanthanoids.